Hi everybody. Well, let's begin our discussion over the questions on statistics. The first question says the difference between the highest and the lowest value of the given observations is called what? Now you know that out of all the given observations, if I pick up the largest valued observation and the lowest valued observation and I actually create the difference between the highest and the lowest, that is called my range, right? And the difference between the upper and the lower limit of the given class interval is called what? I have a class interval A to B. What is B minus A called? It just gives you the class size. What is the width of that class interval? It gives you the class size, right? Let's talk about the next question. It says that in the class interval 10 to 20, 20 to 30 and so on. So it is just giving you a format of the class intervals taken. The class intervals are like this: 10 to 20, 20 to 30, 30 to 40 and so on. It is saying 20 is taken in which class interval? Now you know that this is the exclusive case of writing class intervals, right? In which case what happens? The upper limit is not included in the class interval, but the lower limit is certainly included in the class interval. So in the class interval 10 to 20, values from 10 to 19 are there, 20 is not there. 20 is actually in this class interval, that is in 20 to 30, because it is sitting as the lower limit, and lower limit of the class interval gets included in the class interval. In the class interval 20 to 30 are values from 20 to 29, 30 is excluded. So 20 is excluded in 10 to 20 class interval, but 20 is included in 20 to 30 class interval. So 20 is actually sitting in 20 to 30 class interval. Next you have the mid value of a class interval is 42. What do you mean by mid value? Mid value means class mark. It says class mark of 20 to 30, or which class interval? Okay, so class interval is not given to you. The mid value of this class interval, suppose x to y, that is class mark of x to y class interval is given to you as 42. This is my class interval. If the class size is 10, so class size of x to y class interval is 10. Then find out the value of upper limit and lower limit, that is x and y. What is class mark of a class interval? Y plus x upon 2, that is the mid value of that class interval, gives you the class mark. So this means if x to y is the class interval, its class mark is 42, that means x plus y upon 2 is 42. And what is the class size of x to y class interval? Width. Upper limit minus lower limit. So you have y minus x is 10. If x plus y is 42, that means x plus y is 84. So you have x plus y is 84, y minus x is 10. Just solve these two equations. You have x plus y is 84 and minus x plus y, or y minus x is 10. When you add, you get 2y equals 94, which implies y equals 94 upon 2, that is 47. And if y is 47, what is x? Minus x is 10 minus 47. So minus x is minus 37, or x is 37. So your class interval is 37 to 47. You can see that if 37 to 47 is the class interval, what is the class size? 47 minus 37, which is 10. So yes, y minus x is 10, or class size of x to y class interval is 10. Moreover, what is the mid value? 47 plus 37 upon 2. 47 plus 37 is 94. 94 upon 2 gives you what? 7 plus 7 is 4, it is 84. 37 plus 47 is 84 upon 2. When you do, you get 42, and therefore class mark of 37 to 47 class interval is 42. So your class interval is 37 to 47. What is the upper and lower limit? Upper limit is 47, lower limit is 37. Clear? Let's look at the next question. It says that the following observations have been arranged in ascending order. So the observations given to you have already been given to you in an arranged fashion in the ascending order format. if the median of the given data, now see, first of all you have to remember this, that whenever the observations are given to you, this collection of individual observations are given to you, before finding the mean of such a data, you need to arrange them in ascending or descending order. So if the question is talking about median, I have to be sure that the given data is in some form of arrangement. It is already guaranteeing that these values are being arranged in the ascending format, so we don't need to worry about that arrangement. Median is given to be as 63, find the value of x. Median is given as 63, how do you get the median? You count the number of observations after arranging them in ascending or descending order. Right now they are arranged in ascending order, just count the number of observations, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your number of observations is 10, which is an even number. And therefore you know median is what? It is value of n by 2 plus 1th upon 2 observation. That means you catch hold of the n by 2th observation, 10 by 2th observation, that is 5th observation, plus 10 by 2 plus 1, that is 6th observation, divide their sum by 2. That means 5th plus 6th observation upon 2. What is the 5th observation? Count now. It's already arranged. So the places, the positions of elements are now fixed. First, second, third, fourth, fifth. Fifth value is x. Sixth is x plus 2 upon 2. This gives you 2x plus 2 upon 2, which is x plus 1. So your median is coming out to be x plus 1, but median is already given to you as 63. So you are getting 63 equals x plus 1, or x is 63 minus 1, that is 62. Cool enough? Next question says that 30 children were asked about the number of hours they watched TV programs in the previous week. The results were found as follows. Okay. So these are the number of hours, 1 hour, 6 hours, 2 hours, 3 hours, 5 hours and so on up till 12 hours. Make a grouped frequency distribution table for this data, taking the class width as 5 and one of the class intervals is 5 to 10. So they are giving you one of the class intervals. This doesn't mean that you have to begin your class intervals with this class interval. So we are going to first of all talk about class intervals. The next column is of tally marks, and the third column is of respective frequency. Okay. Now see, if you look at the data, minimum number of hours is 1, right? That means I cannot keep 5 to 10 as my first class interval because there are hours less than 5 as well. So let me begin from 0 to 5. If I take 0 to 5 as my first class interval, I will actually be considering the values 0, 1, 2, 3 and 4. 5 will be excluded because next class interval will be 5 to 10. So when upper limit of one class interval is lower limit of the next class interval, I am talking about the exclusive way of making the frequency distribution. So I will be beginning from 0 to 5, then 5 to 10, 10 to 15, 15 to 20. Do we need more intervals? Let's see. Maximum here is 17, yeah. So that much will be covered in 15 to 20 hour range. We don't need 20 to 25. There is no data concerning or lying between 20 to 25. Is it clear? This is satisfying both the conditions. One of the class interval is 5 to 10 and the class size of each class interval is 5. Clear? This is the exclusive case. Please mind it. In the interval 0 to 5, I am considering 5 values 0, 1, 2, 3, 4. 5 is not there. In the interval 5 to 10, again 5 values, 5, 6, 7, 8, 9, 10 is not there. So upper limit is not included in the class intervals, lower is included and everything in between them is included. Now, between 0 to 5, let's see, 1, 2, 3, 5 is not included. Between 0 to 5, this is there, this is there, this is there, then this is there, this is also there, this is there, and that's it. This is between 0 to 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is the frequency. 10 students or 10 children are there out of 30 children who are watching television for 0 to 5 hour range. That means 0, 1, 2, 3 or 4 hours. Next we have 5 to 10. So 5 is there, 6 is there, again 5 is there, 8 is there, 8 is there, 10 is you cannot include, then again 8 is there, 6 is there, 8 is there, 5 is there, 9 is there, 6 is there, then again 8 is there, 7 is there, that is it, right. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13 is the frequency here. Next is 10 to 15, 10, 11, 12, 13, 14, that's it. Here we have covered all 10, 11, 12. So this is there, 10 is included, this is included, 15 we cannot include, 10, 11, 12, 13, 14, yes. Okay, 10 to 15. So how many values here you have? 1, 2, 3, 4 and 5. So 5 is the frequency of 10 to 15. 15 to 20, 17, 15 and that is it, 2. It is 2. If you will add, you will get 30. So out of 30 children, 10 children are watching television in this much range of hours, 13 children are watching television for this much range of hours, 5 are watching television for this much range of hours and 2 are watching television for this much range of hours. This is my group frequency distribution. Let's just draw the tally marks. 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 13, how will you write 13? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 5, 1, 2, 3, 4, 5, 2, 1, 2. Clear? Let's move to the next question. It says that the relative humidity of a certain city for a month of 30 days was as follows. Construct again a group frequency distribution table. Now the class size is not mentioned, but the class intervals are given, just 2 are given. Okay, so with taking the idea of class size from these class intervals, I am going to write all the class intervals. It also asks you which month or season do you think this data is about and what is the range of this data. Let's first talk about the group frequency distribution. So I'll have class intervals, again tally marks and frequency. Clear? Now it's given to you 84 to 86, there is no value beneath 84, so I am going to take 84 to 86 only as the first class interval. Next is 86 to 88, so next will be 88 to 90. What is the class size? Of course you can judge the class size, it is 2. In 84 to 86, what am I including? 84 and 85, that is it. 86 is not included, 86 is included in this class interval. It is again the exclusive case. Then 90 to 92. 92 to 94, 94 to 96, 96 to 98. Can I stop over here? Okay, so let me see. I have numbers beyond 98 as well. Let me take 98 to 100. But I don't have anything beyond 100, so I stop over here. Clear? How many values are there between 84 to 86? Now please mind it, when I am saying between 84 to 86, I am just talking about 84, 85, not 86. That means anything between 84 and 86, including 84, excluding 86. So here between 84 and 86, so I have what? This is not there, this is not there, 84 to 86, here I have nothing, this is there. And here also I have nothing. So 1. 86 to 88. 86 to 88, this is not there. 86 to 88, this is there. 1. And that is it. This is also beyond 88. So you have just 186.5. 88 to 90, yes, you have this 89.2 and that is it, because 90 you are not allowed to include. So again 1. 90 to 92, okay, let's see, 90 to 92, this I will be including. 90 to 92, no, yes, this is also there in 88 to 90, you have one more value, that is 89, so this is 2. Between 90 to 92, I am just able to fetch that one, this is also there, 90 to 92, and that is it, 2 values are there between 90 to 92. 92 to 94, let's search. 92 to 94, you have 1. 92 to 94, this is also there. 92 to 94, this is there. This is there. 92 to 94, this is there. This is there. This is also there. And that is it. So what all you have? 1, 2, 3, 4, 5, 6 and 7. 7 values are there between 92 to 94. Is it clear? Try to find out how many values lie between 94 to 96, 96 to 98, 98 to 100, and we'll be getting back with the same question. Okay, so let's continue. Between 94 to 96 we have to find out. 94 to 96, this is there. 94 to 96, 94 to 96, again 94 to 96, 94 to 96, 94 to 96, that is it. So how many we have? 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5, 6, 6 are between 94 to 96. 96 to 98, I have this. 96 to 98, this is there. 96 to 98, 96 to 98, 96 to 98. Here also this is there, that is it. So we have 1, 2, 3, 4, 5 and 6 again. 6 values are between 96 to 98. 98 to 100, I have 1, 2, 3, 98 to 100, rest everything is, yeah, so 4. 1, 2, 3 and 4 values are there here. Is it clear? The moment I have captured the frequencies, let's just add 6 plus 4, 10 plus 6, 16, 16 plus 4, 20 plus 3, 23, 25, 26, 27, 28 and 29. Let's just try to see what is actually the data about. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Let's just see where have we committed a mistake. Let's add once again. 6 plus 4, 10 plus 6, 16, 16 plus 2, 18 plus 2, 20. This is 27, 28 and 29. Let's just try and check. Once more, let's check. That is what gives you a hint about checking your data again. So between 84 to 86, between 84 to 86 you have what all values? This is there, that is it, 84 to 86, nothing else. So the frequency here is 1, that is correct. 86 to 88, 86 to 88 you have this is between 86 to 88. Rest, nothing is there between 86 to 88, fine. So 1 again. 88 to 90, you have this and you have this, 2, so 2 I have written over here. 90 to 92, nothing is here. 90 to 92, this is there, right? Here, there is nothing, here, there is again this. So the frequency is 2, right? Then 92 to 94, let's see, you have 1, 92 to 94, this is also there, 92 to 94, this is also there, this is also there, 92 to 94, this is there, 92 to 94, this is there, that is it. So you have how many? 1, 2, 3, 4, 5, 6 and 7. 7 we have written in 92 to 94. 94 to 96, okay, so here there is nothing. 94 to 96 you have 95.1, 94.2, 94 to 96, 94 to 96, 94 to 96. Here you have 94 to 96, right? How many you have? 1, 2, 3, 4, 5 and 6. So you have written 94 to 96 as 6. 96 to 98, let's see. Here there is nothing. 96 to 98 you have this. 96 to 98 you have this. 96 to 98 is this, is this, is this, is this, is this also, and that is it. So you have 1, 2, 3, 4, 5 and 6 again. 96 to 98 is 6. 98 to 100 is the rest of the data, which is involving 1, 2, 3, and you have your fourth value and you have your fifth value. So here you have 1, 2, 3 values. Apart from this you have, what is the value here? Yeah, so 98.3. Is it clear? Quickly add up again and then we are going to move ahead with the next question. Okay, so guys, here we actually have what? If I count this, this is 1, 2, 3, 4, 5, 6 and 7. So 7 values are actually lying in 96 to 98 interval. So this is 7 and that gives us the total of 30. You can always check your total to be coming out 30 if you want to verify that your frequency column is marked correct. So let's just draw the tally marks. This is 1, again 1, then 2, then 2, then 7, 5, 6 and 7, then 6, 1, 2, 3, 4, 5 and 6, then again 7, so 1, 2, 3, 4, 5, 6 and 7 and then 4. Clear? Let's move to the next question. It says that given below are the seats won by different political parties in the polling outcome of a state assembly. Draw a bar graph. Draw a bar graph. Let's first move to the backward question. It was also saying which month or season do you think this data is about. If you remember, in the group frequency distribution, the maximum values of frequency I was getting corresponding to 94 to 96, 96 to 98, right? That means the humidity level is higher and higher. That is getting the maximum frequency. That means here it's talking about the humid season or the rainy season, because the maximum frequency is against humidity levels which are very, very high. What is the range of this data? The maximum value, as you can see, is 99.2. That is the maximum value. And what is the minimum value? Minimum value is 84.9. So if I talk about 99.2 minus 84.9, let me just see, there is no value less than 84.9 and there is no value greater than 99.2. What you get? You get 14.3 as the range. Range is maximum value in the observation minus the least value in the observation, and that comes out to be 14.3. Now let's move to the next question. As it was saying, we have to draw a bar graph for this, right? And which political party won the maximum number of seats I have to show. So how do you draw the bar graph? You take this vertical line, perpendicular to it is the horizontal line. This is your x-axis, this is your y-axis. On the x-axis, you're going to mark the political parties, and on the y-axis, you will be marking the number of seats won. So I will be taking on the y-axis one big division is of 10 units so that I can incorporate all the values. Fine. So you have 10, 20, 30, 40, 50, 60, 70, 80, that is it. You have maximum is 75. So all values will be incorporated. And you have political parties. So here what will be I doing? At equal distances I will be marking A, B, C, D and all on the x-axis, right? Because in the bar graph you want each bar, each rectangle to be of the same size, and they should be at equal distances. Between any two bars there should be equal size, equal gap, equal spacing. So 1 unit I take, 1 unit and then A, then again 1 unit gap B, 1 unit gap C, 1 unit gap D, then E, then F. Is it clear? Now corresponding to A, I am having 75, so here is 75, right? So what I do, I move back a little and front a little. what I do, I take 0.5 here, 0.5 here, so this exact width is 1, and I draw my bar of height 75. Is it clear? This is 75. Then B corresponds to 55, so I move 0.5 here, 0.5 here, so that exact width of the rectangle again is 1, 55 is somewhere here, so I go and take the height of this rectangle to be 55. Then you have C corresponds to 37, this is 37, I move 0.5 here, 0.5 here, 37 is somewhere till here. Of course, you can draw it precise with your scale. This is 37. Then you have D as 29, I move 0.5 here, 0.5 here, 29 is somewhere here, so you have, this is 29. And then you have E as 10, this is 10, so I move 0.5 here, 0.5 here, and this is my rectangle of width 1, fine, height 10. And F is corresponding to again 37, so you have it of the same very height. Move 0.5 before F, 0.5 after F to get the width of the rectangle as 1, and height is correspondingly 37. So you can see between each of the bars, between each bar I have distance of 0.5, right, and each bar is of width 1. So they are equal sized and there is equal spacing between any two. Is it clear? You can write over here parties, and you can write over here what? Seats 1. Clear? Let's look at the next question. 100 surnames were randomly picked up from a local telephone directory and frequency distribution was drawn. Now before I move ahead, here also it is saying which political party won the maximum number of seats. You can clearly see a political party is the party which is winning the maximum number of seats. Also through the bar graph you could see that the bar of corresponding to A, bar corresponding to A was having the maximum height. Fine. So what we have to do here, it is saying that there are 5 children whose basically, this is actually the surnames, okay, and the letters in the surnames are here. This is not age. It is actually that 5 children are there. 5 children are there whose, or 5 people are there whose surname is containing 1 to 4 letters. 30 are there whose surnames are containing 4 to 6 letters. 44 people are there whose surnames are containing 6 to 8 letters in English. And 16 people are there whose surname is containing 8 to 12 letters. And 4 people are there whose surnames are containing 12 to 20 letters in English. So what basically is supposed to be done, if I talk about this question, you are supposed to actually draw a histogram and represent this data. That is what the question is actually. You need to draw the histogram to represent the data. In here, if I talk about drawing the histogram, the class intervals that you can see are of unequal size. 1 to 4, 4 to 6, 6 to 8, 8 to 12, 12 to 20. Of course, there is continuity maintained because upper limit of one is the lower limit of the other, but actually there is difference in the class size of all the class intervals. It's not the same. How do you draw histogram? For the data, when the class intervals are continuous but of unequal class size, what we do, we write the class intervals. We don't change them. We write the class intervals as it is, 1 to 4, 4 to 6, 6 to 8, 8 to 12 and 12 to 20. It is of course an exclusive case. Upper limit is not included in the class intervals, lower is included. We write the frequency, but not with this frequency are we going to draw the histogram. What is the frequency? 5, 30, 44, 16, 4. And here we write the adjusted frequency. That is what you do when you have class intervals of unequal size and they are continuous. Adjusted frequency. What is adjusted frequency? It is what? It is h upon class size into frequency. What is h? H is the least class size. So out of all of this, in 1 to 4, class size is 3, 1, 2 and 3. 4 to 6, class size is 2. 6 to 8, class size is 2. 8 to 12, class size is 4. 12 to 20, class size is 8. Okay? So minimum class size is 2. So here my H is equal to 2. So 2 upon class size into frequency. 2 upon, what is the class size of 1 to 4? 1, 2, 3. It is 3 into frequency. Right? 2 upon class size into frequency. Then you have 4 to 6. Here you have 2 upon 2 into frequency. Then you have 6 to 8. So 2 upon again 2 into frequency. Then you have 8 to 12, 2 upon 8 to 12 is 4 into frequency is 16. And then you have 12 to 20, 2 upon 8 into frequency. Find out the adjusted frequencies quickly and try to draw the histogram with the help of first and the third column and see what the histogram is trying to tell you. Okay guys, so I hope you have evaluated the frequency, but let me just tell you, if there are 100 surnames, that means 100 surnames were evaluated and the data was collected corresponding to 100 surnames, this is going to add up to give you 100, just make 5 as 6 and now the data is correct. Of course, this is not age, this is number of letters, okay, number of letters and number of different people having those surnames. So let me write number of just surnames, okay. Fine, that's actually the correct data. There are 6 surnames consisting of letters 1 to 4. 4 to 6 letters are there in 30 surnames, 6 to 8 letters are there in 44 surnames, 8 to 12 letters are there in 16 surnames and 12 to 20 letters are there in 4 surnames. You have to draw a histogram for that. Fine. So as you are calculating the adjusted frequency, here the frequency is 6. So this will be 2 upon 3 into 6. What will be my adjusted frequency? Tell me. This gives you 4, this gives you 30, this gives you 44, this gives you 8 and this gives you 1, right? This is 4, this is 30, this is 44, this is 8 and this is 1. Now with the help of first and third column, as I said, you will be drawing the histogram. So what is going to happen in here in the case of drawing the histogram? On your y-axis you will be plotting the adjusted frequencies and on the x-axis you will be plotting the very class intervals. So 1 to 4, 4 to 6, 6 to 8, 8 to 12, 12 to 20. What I am going to do is, I am going to begin with 1, then you will have 4, 1 to 4, or let me write 1 to 2. Fine, 1, 2, maximum is till 20, so you can plot 3, 4, 5, 6, 7, 8, 9, 10 up till 20, or what you can do is, just take it that way, that one big division is of 1 unit. So you draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you have 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. One big division is of 1 unit in the x-axis to mark the class intervals. And here you have adjusted frequencies 4, 30, 44, 8, 1. Just take it to be one big division is of 2 units. So you take it as 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, or let me take it to be, let me not take it to be of 2 units because we won't be able to incorporate 44 over here. So let me take it of 4 units. Let me take it off 4 units. So you will have 4, 8, 12, 16, 20, 24, 28, 32, 36, 40 and 44. So one big division on y-axis I have taken off 4 units and one big division on x-axis I have taken off 1 unit. Now nothing, you have to do 1 to 4, frequency is, adjusted frequency is 4. So 1 to 4, that means your rectangle is going to have width equal to the width of this class interval and height is going to be 4. 4 is still here, so you have it, the first rectangle like this. This is your first rectangle, frequency is 4, adjusted frequency. Then you have 4 to 6. 4 to 6 frequency is 30. So 30 is going to be here. 4 to 6 frequency is 30. It will begin from 4, end at 6. Clear? 4 to 6 frequency is 30. This is the class, this is rectangle having width equal to the width of the class interval 4 to 6 and height is 30. Next is 6 to 8, 44. So this is 44, 6 to 8. This is 6 to 8 and that's the rectangle corresponding to this class interval having frequency 44. Then you have 8 to 12 is 16. So you have it to be 16 in 8 to 12. So you begin at 8, you end at 12. This is how much? 16. And then you have 12 to 20. 12 to 20 you have 4 as the frequency. So this is it. And this is your required histogram. Is it clear? Next question says, in a mathematics test, what is happening in this mathematics test? It's given to 15 students and following marks out of 100 are obtained. These are the marks, find the mean, median and mode of this data. To get the mean, you are already first of all given that total number of these marks are 15. So you have sum of observations upon total number of observations. Okay, sum of observations upon total number of observations. Sum of all these values 41 plus 39 plus 48 plus 52 plus 46 plus 62 plus 54 plus 40 plus 96 plus 52 plus 98 plus 40 plus 42 plus 52 plus 60 whole upon number of these observations, which is 15. When you obtain the answer, you obtain it as 822 upon 15. You can evaluate the answer, that would be your mean. In order to get the median, we first of all need to arrange the data in an ascending or descending order. So if I look at the data, minimum value is 39. So you begin with 39. Then you have 40. Again you have 40. So you have 40 and then again 40. Then you have 41 and you have just 141. Okay. Then you have 42 and again you have, no, just 142. So you have, that's it, 142. After that you have 43, you don't have 43, 44, 45, 46 you have, right? Then 47 you don't have, 48 you have, this is 48, 49, 50, 51, 52 you have, there are 3 52s. After that you have 54, then you have 62, 60 and then 62, 60, 62, 96 and then 98. I have arranged the data in the ascending form 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. These are my 15 values in the data arranged in the ascending format. Each value now has a fixed position. This is first observation, second, third, fourth and so on, 15th observation. Count the total number of observations. It is 15, which is odd number. So what is my median? It is 15 plus 1 by 2th observation, right? If n is odd, then n plus 1 by 2th observation is my median. That means 16 by 2, that is 8th observation. What is the 8th observation? Here you are going to look, not in this design. In this design, when you have arranged it in the ascending form. This is first observation, second, third, fourth, fifth, sixth, seventh and eighth. Eighth observation is 52. It is this observation which is dividing this data into two equal parts. Number of values below 52 is same as number of values above 52 in value, in magnitude. Next, it is talking about mode. It's very easy to see what is going to be the mode. The value which is having the highest frequency, that means it is occurring for the maximum number of times. You can clearly identify 52 is the value which is occurring for the maximum number of times. So mode is going to be 52 since it occurs for 3 times. That is maximum. Fine. Moving to the next question, it says that the length of 40 leaves of a plant are measured correct to 1 millimeter and the obtained data is this. Okay, fine. It is represented in the following table. I have to draw a histogram to represent the given data. Now, if you look at the class intervals carefully, I have to draw a histogram, right? These class intervals are not continuous. So, I will first of all make them continuous. How do we do that? We alter these class intervals. What do? A to B class interval is replaced by A minus h by 2 and B plus h by 2. That happens in every class interval. What is h? Lower limit minus upper limit. Lower limit of one class interval minus upper limit of the previous class interval. Here if you see, h is 1, 127 minus 126 is 1, or 136 minus 135 is 1, or 145 minus 144 is 1. Any way you can do, lower limit of one class interval minus upper limit of the previous class interval gives you h. This is your h. So what you are going to do, you will be replacing class intervals by new class intervals. A to B will be replaced by A minus h by 2 to B plus h by 2. So 118 minus 1 by 2, that means 118 minus half is 117.5 and 126 plus half is 126.5. Similarly, 127 minus half, 135 plus half, 136 minus half, 144 plus half, 145 minus half, 153 plus half. Then you have 154 minus half to 162 plus half. Then 163 minus half, that means this is 162.5, and 171 plus half, that means 171.5. Then 172 minus half and 180 plus half. You can clearly see now upper limit of one is lower of the other and therefore this has become continuous. Now we write the frequencies. Frequencies is 3, 5, 9, 12, 5, 4 and 2. Now it's very easy for you to draw the histogram. Let's draw it. Okay, so we have 117.5. It's beginning from 117. I will be drawing a kink in the beginning, right? 117.5. Then you have 126.5. So you take the division of how much? 126.5 minus 117.5. This gives you what? 9. Right? You know this? 16 minus 7 is 9. So you take one big division of 9 units over here. So 117.5, then 126.5, then 135.5. Then you take 144.5. Then you take 153.5. Then you take 162.5. Then you take 171.5. And then you take 180.5. On the y-axis, what is the scale you want to take? You can take it as 1, 2, 3, 4 up till 12 as well, or you can take 2, 4, 6, 8 and so on. So I take 1, 2, 3, 4 up till 12, 6, 7, 8, 9, 10, 11, 12. So one big division is of 1 unit only I am taking on the y-axis. Values are small, I can incorporate all 12 values. So I take from 1 to 12. Now you have 117.5 to 126, it is 3. So you have it like this. That's how you draw 3. The next is 5. So you have it as 5. Next is 9. So you have it till 9. Right? So of course you can draw it like this. 9, then you have 12. This is the max 12. Then you have 5 and then 4 and then 2, so you have 5. Then you have 4. And then you have 2. So 2 is here. This is 2 and that's your histogram. Clear? Next question says, first of all it says, is there any other suitable graphical representation for the same data? Yes, of course you can also draw frequency polygon for the same data, right? Is it correct to conclude that the maximum number of leaves are 153 millimeters long? 153 millimeters long, 153 millimeters long. Let's come to this data. 153 is included in this class interval. 153 is included in this class interval. This has frequency as 12. Can we say that maximum number of leaves are 153 millimeters long? Yes, 12 is the maximum number of leaves whose length is lying in this range. But in this range, many values are lying, 9 values are lying, 145.5 up till 153.5 class size is 9. So, you know, many values are lying in this particular range of 143.5 to 153.5. Lying in this range is the maximum number of leaves having length. Maximum number of leaves are having length lying in this range, but that doesn't mean exact 153 only is the maximum length or the largest length. Okay, so this is wrong. Of course, the maximum number of leaves are having length in this range, but in this range 153 is lying, but only 153 is not lying, right? So I cannot say 153 is that particular length which maximum leaves are having. Okay. Next question says that the following table gives the distribution of students of 2 sections according to the marks obtained by them. Represent the marks of students of both the sections on the same axis. You have to present by 2 frequency polygons, okay, on the same axis. So here if I talk about section A's data, you have class intervals as the marks and frequencies you have. Whenever you are talking about frequency polygon, first of all you have to see whether the class intervals are continuous or not. So they are continuous in both the cases, right? These are 2 sets of data. So directly move on to the class marks. Class marks. So you have 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Class mark would be what? 0 to 10. What is the mid value? It is 5. Here mid value is 15, here mid value is 25, here 35 and here 45. Frequency is 3, 9, 17, 12 and 9. I am only concerned with this column and this column. Another case, let's write class intervals. You have 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Right? You have frequency as 5, 19, 15, 10 and 1. Right? What is the class mark? Again, class intervals are continuous, so not a problem. 0 to 10, again class marks are the same, 5, 15, then you have 25, 35, 45. Remember in frequency polygon what we did, we used to add two imaginary class intervals, one before the first one and one after the last one. So here I am going to add, this is -10 to 0 and here will be 50 to 60, both with frequencies 0, right? Both with frequencies 0. Class mark would be what? From -10 to 0, it will be -5, and 50 to 60, it will be 55. Similarly, here also I will be adding -10 to 0, frequency 0, class mark would be -5. Here I will be adding 50 to 60, frequency 0, class mark 55. Now we just need to do one thing, what? Draw class marks and the frequencies. So let's do that. Class marks and the frequencies, class marks are 5, 15, 25, 35, 45. So let's take that only. This is 5, or let me take it, one big division is of 5 units. Let me take that on the x-axis. So you have 5, 10, 15, 20, 25, 30, 35, right? So you have these class marks, or rather than that, because I am only and only interested in plotting class mark comma frequency, let's just take the class marks. What do you get? 5 to 15, what is the gap? 10. 15 to 25, what is the gap? 10. 25 to 35, what is the gap? 10, and 35 to 45, gap is 10. So I just take one unit or one division of 10 units, that is going to resolve my problem. So I take, begin from 5, then 15, then 25, then 35, 45. Clear? And I also have to take -5. So -5 is going to lie somewhere here. This is your, where? This is your -5, this is 0. Clear? On the y-axis you have to plot the frequencies. Let me take it of, one big division is of 2 units. So you have 2, 4, 6, 8, 10, 12, 14, 16, 18. Is it clear? Now it's time to talk about plotting the points. So first you will plot class mark comma frequency, -5 comma 0. Then you have 5 comma 3. So somewhere here is 3. Then you have 15 comma 9. So 15 comma 9. Then you have 25 comma 17, somewhere here is 17, so 25 comma 17, and then you have 35 comma 12, so you have 35 comma 12, and then 45 comma 9, so here is 9, 45 comma 9, and then you have 55 comma 0, let's draw 55 as well. 55 comma 0, so this is 55 comma 0. Let's just join this by straight line segments. This is your first frequency polygon. This is section A, this data, right? Next you have here as well, -5 comma 0 again. Then you have 5 comma 5, 5 comma 5 here. Then you have 15 comma 19, so this is 10 and somewhere here is 19, 15 comma 19. Then 25 comma 15, so 25 comma, this is somewhere here is going to be 15, 25 comma 15. Then 35 comma 10, this is 12, this is 10, 35 comma 10. Then 45 comma 1, so here is 1 somewhere, 1, and also again 55 comma 0. Let's join this again by straight line segments. And then you have this value, then this value, then this value, then you have this value, and then this value. This is for section B. Both the frequency polygons have been plotted on one axis. The question is, compare the performance. Now please try to see this. Between 0 to 10 in section A are marks of 3 students, okay, and between 0 to 10 here are marks of 5 students. So, you know, more poor students in section B. If I talk about this, 30 to 40, 12, 30 to 40, 10, 20 to 30, 17, 20 to 30, 15, 40 to 59, 40 to 50, just 1. So obviously A has students performing better than section B. That is the conclusion we can draw about the performance of students, that in A class the performance is better than it is in section B. And that completes my discussion over all the questions. That's it from my side. Thank you.